When taking this lesson, ensure that your speaker volume is on and at a comfortable level. You can use the navigation controls to move to the next screen of the course or to the previous screen. You also have the option to turn the audio on or off. In each screen, you'll find a script tab, which you can click to display the full script of the audio track. The Menu tab lists all screen titles of all screens contained in the course. You can click on a screen title to move directly to that screen. This course includes knowledge checks at the end of each lesson to quiz you on what you have learned so far. Please make use of all of these resources, as they are designed to help you reinforce the important learning objectives of the lesson. This course contains 2 lessons. Lesson 1 discusses the challenges of traditional disaster recovery, DR, as well as the capabilities and business use cases of VMware vCenter Site Recovery Manager. Lesson 2 identifies the terminology, core components, and high-level implementation requirements of Site Recovery Manager 5.8, including storage dependencies. This is Lesson 1. At the end of this lesson, you will be able to describe the causes and impacts of a disaster on an organization, describe the challenges and processes of traditional methods of disaster recovery, explain the benefits and process of disaster recovery, DR, with virtual machines and Site Recovery Manager 5.8. List key use cases for and the benefits of Site Recovery Manager, and list the failover sites possible with Site Recovery Manager, as in where can the DR site be located. A leading market research company, Forrester Research, completed a study in the second quarter of 2014, asking the following question, among others. As a result of your most significant disruption, which of the following turned out to be the greatest impacts to your organization? The number 1 reason by far was loss of employee productivity, double that of lost business opportunities or lost revenue. As bad as that is, however, it pales in comparison to this statistic from the National Archives and Records Administration. 93% of all businesses that lose their data centers for 10 days or more go bankrupt within 1 year. The cost of not having a functioning DR plan is astronomical if the unthinkable happens and disaster strikes. And thus a DR solution must be thought of like insurance, as something you need to protect yourself but hope never to use in real life. What are the most common causes of disasters? According to that same Forrester's research study, the number 1 reason was a simple power outage. Power outages may be very short in duration, or they may last for hours, days, or even weeks. Few businesses have the generator fuel to sustain outages anywhere near that long. This type of disaster is often not predictable in advance, unless it occurs as part of a storm system, such as a hurricane. Speaking of that, the 4th most popular reason was hurricanes. The major difference between this type of disaster and the others is that you know they are coming days in advance and have time to implement a failover strategy in advance, a preventative failover. IT hardware failure was the number 2 reason, and human error was number 3. These error types are not easily predictable, and the impacts may be relatively simple to repair or may lead to outages of hours to days. There are many challenges associated with traditional DR techniques. The challenges can be grouped into 3 categories, namely expense, complexity, and reliability. From a cost standpoint, these can be enormous. Costs include a second facility that can be used in the event of a disaster, whether or not it is used for other operations, the extra hosts and storage, and possibly the extra software licenses required for failover. On average, the cost of DR is over $10,000 per application. This doesn't even count the cost of staff to set up, manage, maintain, test, and implement the DR plan. Next, from a complexity standpoint, for the DR plan to work well and reliably, the hosts cannot be significantly different from those on the production site. Otherwise, some backups may not restore successfully. Storage may need to be replicated and made available to the hosts during a disaster. Networking may need to be reconfigured for the IP address space of the DR site, and so on. All this complexity leads to the third problem. DR plans are often unreliable. Due to the expense and difficulty involved in testing, it is often only done once a year or less. This means that if a disaster strikes, staff commonly run into unforeseen problems and may not react quickly enough because they are unfamiliar with the DR tasks. These delays can prolong the outage. Let's look at some of the complexity issues raised in the previous slide in more detail. Firstly, in most cases, matching storage hardware is required for proper data protection, making it very difficult and expensive to change storage vendors, or even to upgrade the existing storage solution. Secondly, in a traditional, non-virtualized scenario, each application requires one or more servers, and those servers must be duplicated at the DR site for failover purposes. The servers can't be too old, or the backups may not restore properly due to differences in hardware, attached devices, BIOS, and so on. In addition to these technical challenges, there can be additional human issues. One of the biggest is often the management silos of expertise. For example, the SQL administrator may know nothing of any other application, such as Exchange, nor anything of the storage or network requirements to get it working on the other site. Same applies to the network and other IT administrators, not to mention the other application administrators. Finally, all of these challenges lead to unreliable manual recovery processes that are often time-consuming and may not work as expected. All of this complexity is reduced with the software-defined data center, SDDC, where all the servers are virtualized. In this environment, the need for physical servers to host the virtual machines is reduced, saving power, cooling, and the number of servers. The servers can also be of different types, even different architectures, such as AMD and Intel, allowing the current production servers to be repurposed as DR servers when new production servers are required as part of the normal server lifecycle. This repurposing saves on capital expenditures, CapEx, on both the production and DR sides, lowers the total cost of ownership, TCO, and increases the ROI, return on investment. In addition, storage does not need to match, potentially using completely different types of storage on each side, such as SAN for production and network-attached storage, NAS, or even direct-attached storage, DAS, including VMware Virtual SAN on the DR side. This further lowers the TCO. The entire process can be automated, reducing complexity and increasing the chances for a quick and successful outcome. The SDDC also enables production to resume at another company location or even somewhere in the cloud. More on this later in this lesson. What will DR cost? Generally, this will depend on what is required for the recovery point objective, RPO. In other words, what is the data interval that can be lost at the end of the DR process? If the answer is no data or only a few minutes worth of data, then synchronous array-based replication is required in conjunction with Site Recovery Manager. This is the most expensive option. On the other hand, if as little as 15 minutes or even a few hours can be lost, then vSphere Replication, VR, can be deployed in conjunction with Site Recovery Manager. vSphere Replication is included, for free, in most editions of vSphere. So there is just the cost of Site Recovery Manager, making this a mid-price solution. Finally, if days of data can be lost, then vSphere Data Protection Advanced can be used in conjunction with its native backup data replication capabilities for handling both local as well as site-level issues. This is the least expensive solution. However, if the value of the lost data is taken into account, it may actually be the most costly option for an organization and the most detrimental to its survival. Site Recovery Manager uses two sites: the protected site where your virtual machines normally run, and the recovery site where they fail over to. Because vCenter is key to orchestrating Site Recovery Manager's activities and must survive any disaster, each site requires its own vCenter as well as its own copy of Site Recovery Manager. However, you only need to license Site Recovery Manager for virtual machines that are protected, irrespective of location. The other major component you need is a replication mechanism, either the native vSphere replication or storage-based replication. The details of these components will be described in detail in Lesson 2. The fundamentals described here are important to understand how Site Recovery Manager works and the various use cases for Site Recovery Manager. Now that you have seen what Site Recovery Manager is and what it can do, let's look at some of the common use cases for it. The first use case is unplanned failover. This is what Site Recovery Manager was originally designed to do: handle unplanned outages at the protected site, such as power failures or earthquakes. Failover can require moving the entire site to the recovery site or just a portion of it. For example, your company may have a policy that any outage longer than 15 minutes requires the company's web servers be migrated. Outages more than an hour require email being moved, and everything else can wait 24 hours before migration. This strategy might be employed in the power outage scenario, where the duration is often unknown but generally short. Failing everything over at once might be used in the event of an earthquake, where the duration and impact is often unknown but generally long. This is the most critical but least often used use case. Site Recovery Manager is designed in this scenario to ensure the fastest RTO, recovery time objective. In other words, the amount of downtime endured. Minimizing the RTO is the key to minimizing the cost of downtime, which averages $145,000 per hour according to Forrester. The second use case is preventive failover, sometimes called disaster avoidance or planned failover. This scenario covers those outages at the protected site of which you have some advanced warning, such as hurricanes, floods, or extended building maintenance. Because the need to fail over is known in advance, Site Recovery Manager has time to gracefully shut down each virtual machine at the protected site, perform one last replication so that no data is lost, and then bring up each virtual machine in a consistent state. Another benefit of this approach is that the failover time will be basically the same every time, assuming you don't change which virtual machines are protected, as opposed to the previous scenario where the time to recognize that a disaster has occurred and then initiate and complete the failover may be much longer and the time is much harder to predict. This not only ensures no data loss, but also complete application consistency, both within the virtual machine and between all the virtual machines that are failed over at the same time. This is the next most critical scenario, but the frequency of use varies widely based on the natural disasters that are prevalent where the protected site is located. The next use case is planned migration. This scenario covers planned movement of virtual machines between data centers, such as data center migrations, data center consolidations, or global load balancing. Similarly to the planned failover scenario, the need to failover is known in advance. Site Recovery Manager has time to gracefully shut down each virtual machine at the protected site, perform one last replication so no data is lost, and then bring up each virtual machine in an application and data consistent state. This is the most common use case for Site Recovery Manager, and planned migration is often a justification to purchase the product, with DR a side benefit. One advantage of Site Recovery Manager for this use case is that the migration can be tested in advance, providing a high degree of certainty that it will work as expected when the actual migration takes place. Site Recovery Manager can also be used to fail back to the original location if desired, for example, in some load balancing scenarios. Another advantage of Site Recovery Manager is that, similar to the unplanned failover scenario, virtual machines can be migrated in stages. It does not have to be all or nothing, which is often important in data center migration scenarios. The final use case is for upgrade and patch testing. This scenario involves using a copy of the virtual machine at the recovery site on an isolated network to test upgrades and/or patches, and leaving the original virtual machine to continue uninterrupted in production. The upgrades or patches could be to the operating system or the installed applications. Once testing has successfully completed at the recovery site, the patches or updates can be applied to the production virtual machines with full confidence that they will work as expected. The virtual machines can be left in this state for as long as necessary to test the upgrades and/or patches. Note that replication is unaffected during this testing. So if a disaster were to strike, the virtual machines could be failed over with no more data loss than the failover scenarios previously described would have. Let's switch from use cases to the benefits of using Site Recovery Manager. First, what is a run book? A run book is a detailed step-by-step set of directions on how to bring everything back online, such as operating systems, applications, and data, and in what order they need to be restarted. The benefit of using Site Recovery Manager is that long, complex run books can be replaced by a simple recovery plan. Run books must be explicit on all of these steps and continuously maintained as software patches, service packs, and so on are applied to keep the procedures accurate, not to mention every time a new server or application is added to the environment. This rarely happens, so the administrators who need to follow these procedures must fill in the missing pieces and steps leading to the problem that run books, which should be step-by-step, are used only as general guides. In addition, recovery administrators must be trained whenever the run book gets updated to understand the changes and to practice and/or get training on the recovery procedures. With Site Recovery Manager, it is the same virtual machine after replication, so the latest patches, service packs, and so on are always applied. The workflow necessary for failover is all defined as part of the recovery plan and automated, thereby eliminating the potential for human error in the recovery process. The next benefit is that all of the use cases previously described can be fully automated and handled with Site Recovery Manager. This applies whether the outage is planned or unplanned, or in the planned migration scenarios. It also applies to the upgrade and patch testing use case. In fact, testing of the recovery process can be done at any time with zero downtime for the production virtual machines. The ability to non-disruptively test as often as desired can be key to regulatory compliance requirements to prove that the DR plan will work when needed. In many industries, these tests occur monthly or even weekly when Site Recovery Manager is implemented. Another great feature mentioned earlier in the course is the ability to not only fail over, but to automate the failback process after the need for the failover has passed. This makes bidirectional migrations much easier and also helps return to normal operations after the disaster has passed, or potential disaster in the event of a planned migration. The third benefit is that the risk that a recovery will not work as expected due to changes in the infrastructure or applications is minimized. In traditional DR testing scenarios, the test is often only completed once per year due to the time and expense required to run the test and due to the possible outage for both the test failover and failback stages. During this time, a lot can change in the machine configuration, operating system, and application. While the test may be successfully completed, it might not work correctly if a disaster occurs some months after the test. For example, an application upgrade may change the underlying data format. When disaster strikes and the DR plan is run, and the patch is not applied because the need for it was not documented in the run book, the data can't be used. An administrator would then need to troubleshoot the issue to determine that the required patch was missing, often substantially increasing the time to recover. With Site Recovery Manager, you can test as often as desired. Not much changes in a week, so there is high confidence that the DR plan will work if testing is done weekly. Any changes to the virtual machine will be replicated, including virtual hardware changes, as well as operating system and application patches. This minimizes the risk of issues at restore time, even if more virtual machines are replicated, causing extra strain on the recovery site. This can be quickly noted and additional resources procured before a real disaster strikes. The final benefit of Site Recovery Manager is the reports that are automatically generated after each test, as well as actual failover. These reports are automatically archived by Site Recovery Manager for evidence to regulators, auditors, and others that your DR plan will work as expected. The reports show detailed step-by-step results of the entire recovery plan, how long each step took to execute, and so on. A list of some of the regulations surrounding DR by industry is listed here for quick reference and is not intended to be exhaustive. As previously mentioned, Site Recovery Manager requires both a protected and a recovery site. The protected site is easy. It is where you currently run your business workloads. But what about the recovery site? If your organization has at least 2 data centers, you can choose to replicate between them as shown here. With this approach, you purchase the necessary physical servers, storage, vCenter and vSphere licenses, and Site Recovery Manager as part of your traditional CapEx process, and use the product as previously described. But what if you don't have a secondary site? What if the CapEx costs are too high for a secondary site? In this case, you can choose to replicate to the cloud using a DRaaS, Disaster Recovery as a Service model, moving the costs of DR from CapEx to OpEx. There are 2 options that can be used in this scenario. The first option is to replicate to a cloud provider who is part of the VMware Service Provider VSPP program. In this case, Site Recovery Manager is used, just as in the on-premises scenarios recently described. The other option is to use vCloud AirDR, which is a VMware-delivered and supported DR option, but which is not compatible with Site Recovery Manager. It does offer many of the same advantages of Site Recovery Manager, however, such as cost-efficient replication, automated failover and failback, and non-disruptive testing. As this course is about Site Recovery Manager, this option will not be described further. Now it's time to check what you've learned. Which of the following are common use cases for Site Recovery Manager? Select 3 options. This is the end of Lesson 1. You should now be able to describe the causes and impacts of a disaster on an organization, describe the challenges and process of traditional methods of disaster recovery, explain the benefits and process of disaster recovery, DR, with virtual machines, list key use cases for and the benefits of Site Recovery Manager, and list the failover sites possible with Site Recovery Manager, as in where can the DR site be located.